A-level math 9709. This is November 2014 P1 question number 10. A curve is such that the double derivative of this curve is given. So we don't have the first derivative, we don't have the original equation. The curve has a stationary point at P. Stationary point का क्या मतलब है कि it's either a maximum or a minimum point when x is equals to 2. x की वैल्यू यहाँ पे 2 है, या अगर ये कर्व है तो यहाँ पे 2 है. State with the reason the nature of this point कि ये maximum या minimum point है. What do we do for that? The only process that we know up till now is double derivative at a particular value of x. If it's negative, you have a maximum point. Negative है तो maximum point है. If it's positive, you have minimum point. So over here we got a maximum point. Simple. That's a 1 mark question. Find expression for dy by dx. I do not know if you've seen my previous videos, but whenever you derivate a function that looks like this, y, if you derivate that, it will become dy by dx. If you double derivate that, it will become d square y over dx square. And this is what is given in the question, right? If they're asking you to find dy by dx, they're asking you to go back. How do you go back? If this black arrow represents differentiation, you integrate to go back. So we will integrate. The integration signs are up here. So this d square y by dx square will become dy by dx. And what I've done is I have rearranged the equation and written it like this. Just brought the x upstairs in the numerator. Now when we integrate, what do? We add 1 to the power. If I add 1 to the power, it becomes minus 2, and I write the same power in the denominator as well. The x that had disappeared has been reintroduced, plus a constant c, right? Now we do not know the value of c, so we're stuck over here. What do we do now on this step? This is when we need to go back and understand this, that we are at a stationary point at P. Stationary point means at x is equals to 2. At x is equals to 2. So there is a certain point P जिसके x coordinate given है, y coordinate अभी नहीं पता. Stationary point is a point at which the slope of that particular function is 0. So dy by dx is representing slope. So instead of dy by dx, I'll simply write 0. That is the slope. And what is the x coordinate for that slope? That is 2. So I'm going to plug that in over here instead of x, and dy by dx is going to be 0. If and when I solve that, I get c is equals to 11. Now that c is equals to 11 is going to go up here, get introduced into that fraction again, and we will finally have our derivative equation. Part C says, given that the curve passes through the point 113, find the coordinates of the stationary point. Which stationary point are you talking about? Point P, the same point that we had up here, jiska x coordinate pata hai, so y, we just need to find the y coordinate. Then what is this point? In the process of solving or trying to solve this equation, you will find that this point will come in handy. 113 will come in handy, and I'll show you why. Currently we are at dy by dx. What if we integrated once again and integrated once more and end up reaching the value of y, the equation for y? So we will do just that. I have rewritten this in a different format, and I've integrated both sides. Once you integrate it, you add 1 to this power, it becomes -1, and you write the same value in the denominator. That's integration. You add 1 to this power, you get 2, and you write the same value in the denominator, and when there is no x, you introduce that. Whatever variable is missing, you introduce that, plus a constant k. This is always there in integration. Let me tell you why. If you have the equation dy is equals to 2x plus c, if you differentiate it will be 2. Where did the c go? It disappeared. So when you are integrating and taking it back, you know there was some number which disappeared. You can just call it k because you don't know it yet. Now that we have this function, take a look. There's one unknown over here, that is k. This is where this will come in handy. The point 113. Instead of y, just plug in 13. Instead of x, just plug in 1 wherever you see x. I mean, we've got it here, we've got it here, we've got it here. And we can find the value of k. Once we have the value of k, you can pick that up and plug this back in over here. Finally, you have that equation. What do? You know that point P had an x coordinate of 2. If in this equation you plug in the value of 2 over here, over here, over here. You finally have the value of y. Which value? This one, 12, and point P is 2, 12. So finally the y coordinate that we did not have here a long time back is finally 12.